So in today's class we shall discuss about integrating factor and what is the role of integrating factor in solving differential equations. Now first there are exact and non-exact differential equations. Suppose this is equation 1 m dx plus n dy equal to 0, and this type of differential equations come under the category dy by dx equal to fxy. These are your first order first degree differential equations, linear differential equations of order 1. Okay, and in this differential equation, this is the typical form m dx plus n dy equal to 0. Now if this is an exact differential equation, then it is very simple to solve this. Now how to know that this differential equation 1 is exact? Now first you will find del m by del y, then you find del n by del x, and then verify that these two are equal. If these two are equal, then your this differential equation 1 is a exact differential equation. For example, suppose I will write y into cos x plus sin y plus sin y plus y whole into dx plus sin x plus x into cos y plus x into dy equal to 0. Suppose this is my differential equation. Now this entire function which is multiplied with dx is called m. This is, I will denote this by m, and this all this expression which is multiplied with dy, I will say this is my n. Okay, then what I will do, I will find del m by del y. I will find del m by del y. Now what is del m by del y? Partial derivative of m with respect to y. Now see, partial derivative of m with respect to y means del by del y into cos x plus this is your sin y plus y. This is equal to, now partial derivative with respect to y, this means here x is a constant. X is a constant. So x is constant, cos x is a constant. So cos x is a constant into derivative y. Derivative y is 1 plus sin y. Derivative of sin y is a cos y plus derivative of y. Derivative y is 1. So this is equal to cos x plus cos y plus 1. Okay. Similarly, now this is my n. This function is n. I will find del n by del x. Now del n by del x. This is equal to del by del x n. What is n? N is your sin x plus x into cos y plus x. So write this sin x plus x into cos y plus x. Now this is equal to del by del x, partial derivative with respect to x. This means you have to treat y as a constant. Now if y is a constant, then sin x derivative is a cos x, cos y. Now y constant means cos y is a constant, so plus cos y constant, you keep it outside. Now derivative of x with respect to x, that is 1, cos y into 1 plus derivative of x, that is 1. So this is equal to cos x plus cos y plus 1. Now see, this is your del m by del y, cos x plus cos y plus 1. Now this is your del n by del x, cos x plus cos y plus 1. So you will write del m by del y is equal to del n by del x. This is equal to cos x plus cos y plus 1. Okay, so this differential equation is the exact differential equation. This differential equation is y into cos x plus sin y plus y dx plus sin x into x cos y x dy equal to 0. This is an exact differential equation. Now let it be equation 1. This is your example number, suppose 1. Now if you find that a differential equation is exact, then how you will solve that differential equation? Now I will write here if m dx plus n dy equal to 0 is exact, suppose this is exact, that means del m by del y must equal to del n by del x, then its a solution is a its solution is given by integration m, but here you have to treat y as a constant, treating y as a constant, plus integration n dy, but here only those terms of n do not containing x, only those terms of n which do not contain x, this is equal to c, this is equal to a constant c. Okay, so now integration m, what was my m? My m is a y into cos x plus sin y plus y. What is m here? M here y into cos x plus sin y plus y. Remember, y into cos x plus sin y plus y. So y into cos x plus sin y plus y dx. Here y as a constant, here y is a constant, plus integration terms of n that do not contain x. You will write here terms of n that do not contain x, only those terms of n that do not contain x. Now what is my n? My n is here sin x, now here is x, so you will not write sin x. X into cos y, now here x, you will not write x into cos y. The third term is x, you will not write x. Okay, so here n is a sin x plus x into cos y plus x. Now there are total 3 terms and all the 3 terms contains x, so you will not write any term of n, so here you put 0 equal to constant, because all terms of n contains x. Okay, now here y is constant, so y into integration of cos x dx plus y constant means sin y constant, so sin y is constant, integration dx plus y is constant, integration dx plus 0, integration is 0 equal to constant c, implies y into cos x, integration cos x is a sin x plus sin y into integration dx is x, that is x into sin y plus y into dx integration x, so x y equal to c. Now this is your general solution. This is called general solution. Here c is an arbitrary integration constant, and this arbitrary constant arises whenever you solve any differential equation. Now this is the procedure to solve an exact differential equation. So now let's solve another exact differential equation. I will write a question here. Suppose I will write here I have found an exercise. Now the question is determine which of the following equations are exact and solve these ones. This is your some exercise. Now the question is determine which of the equations are exact. Write the question 1. Determine which of the following equations. Which of the following equations are exact and solve the ones that are Number 1, i.e. x plus y plus 1 into dx plus x minus y square plus 3 into dy equal to 0. Now here m, what is m? You will write m is x plus y plus 1, and what is n? Here n is x minus y square plus 3. What I will do? I will do del m by del y. Now this is my del by del y, x plus y plus 1. This is equal to, with respect, partial derivative with respect to y. So x derivative is 0 because partial derivative with respect to y. So x, all other variables are constant. So x is constant, derivative of x is 0. Y is over y variable, so derivative of y is 1. 1 is constant, 0. So this is equal to 1. Now del n by del x, del by del x, x minus y square plus 3, partial derivative of x, partial derivative with respect to x. So y is constant, but x, derivative of x is 1, y constant, so derivative 0. 3 is always constant, derivative 0. So this is equal to 1. So you write out the del m by del y equal to del n by del x. Implies given equation, suppose this is your equation 1. So write equation 1 is an exact differential equation, is an exact differential equation. Now if 1 is exact, then how to solve equation 1? Now its general solution is given by integration x plus first I will write the result. What is the result? Now integration m dx plus integration n dy equal to c. Now m, to integrate m, you will treat y as a constant. Now to integrate n, you have to integrate only those terms of n that do not contain x. Do not contain x. Okay. So integration m. What is m? M is x plus y plus 1. What is m? X plus y plus 1. So I will write x plus y plus 1 dx. Okay. Integration m dx, result integration m dx. Here y is a constant plus integration n, those terms of n that do not contain x. Now where is n? Here is n. What are the terms that do not contain x? Now the n has 3 terms, x minus y square plus 3, x y square 3. There are 3 terms. First term, here x is present, so I will not write this term. Okay, I will not write this term. Second term, there is no x, so yes, minus y square will be integrated. 3 will also integrated, so minus y square plus 3. Okay, you will write only this part, minus y square plus 3. These are to be integrated. You will not write x. Those terms which contains x are excluded, are not integrated. So कौन लिखिबा? What I will write? Minus y square plus 3 minus y square plus 3 dy, okay? N dy, integration n dy, okay, equal to c. Now integration x, that is x square by 2. Y is constant, so integration dx, that is a what, integration dx plus integration dx plus minus y square integration y to the power 3 by 3 plus 3 into dy y equal to c. So this implies x square by 2 plus integration dx dx xy plus integration dx dx minus y q by 3 plus 3y equal to c. Now this is your general solution. Understand? So now move to double I. This is your sin x into tan y. Let's do some difficult type of question. Yes, here is one. Triple I, sin x into sin y, sin x into sin y minus x into e to the power y minus x into e to the power y dy equal to e to the power y plus cos x into cos y plus cos x into cos y dx implies. Now say this is your e to the power y plus cos x into cos y dx. So listen here, what is m? Now see, first write it in general form. What is general form? Now general form is m dx plus n into dy equal to 0. So you have to write differential equations in this type of form. Okay, m dx plus n dy equal to 0. So m dx means e to the power y cos x cos y dx. So e to the power y plus cos x into cos y dx. Now bring this term to RHS. So this is minus sin x into sin y minus x into e to the power y dy. Now this is equal to 0. Now here minus I can I can multiply this minus inside, then I will have e to the power y plus cos x into cos y dx plus I can write x into e to the power y in minus sin x into sin y dy equal to 0. Now this is my differential equation. Now here is m. What is m? That is multiplied with dx, that is e to the power y plus cos x into cos y. Now del m by del y, del m by del y. So del by del y e to the power y plus cos x into cos y. This is equal to del y del y partial derivative with respect to y. So treat x as a constant, e to the power y. So this is del y e to the power y. Now x is a constant, so cos x is a constant, so keep cos x outside. So del y cos y. So this is equal to del y e to the power y. This is your e to the power y plus cos x into cos y, derivative is a minus sin y. So this is e to the power y minus cos x into sin y. This is your del m by del y. Now I will find it del n by del x. This is your del by del x of what is x, what is n, what is n, that is multiplied in dy. So x into e to the power y minus sin x into sin y, this is your n. So x into e to the power y minus sin x into sin y, this is equal to, now partial derivative with respect to x. So y is a constant. If y constant, then e to the power y is a constant. So e to the power y, keep it outside, then derivative of x minus y constant means sin y is also constant. So sin y will remain outside, then derivative del by del x, del by del x, del by del x of sin x. this is equal to e to the power y derivative of x is 1 minus sin y derivative of sin x is cos x. Now see del m by del y, this is e to the power y minus cos x into sin y, then del n by del x, e to the power y minus cos x into sin y, both are equal. So you will write hence del m by del y equal to del n by del x, implies the given equation 1 is a exact differential equation. Then its general solution is given by, integration m dx plus integration n dy equal to c. Here y is a constant and here terms without x, x. So integration m, what is m is what? M is a e to the power y plus cos x into cos y, e to the power y plus cos x into cos y, integration m dx. Here y is a constant plus integration of n terms without x, dy. Now let's find what are the terms in n that are without x. n has two terms. First term contains x, second term also contains x, so there is no term without x. So here you will write 0 equal to c, implies y constant means integration e to the power y is constant, so keep e to the power y outside, integration dx, plus y constant means cos y is constant, so integration cos x dx equal to c, c, implies e to the power y in integration dx dx plus cos y integration of cos x is a what? Sin x equal to c. Now this is your general solution. Okay, similarly you can solve the questions. There is another question, that is 1 plus y dx plus 1 minus x dy equal to 0. Now here m, what is m? Here m is a 1 plus y, here n is a 1 minus x. Now del m by del y is a 1, del n by del x is a minus 1. Now these are not equal, so this is a not exact. Okay, so not exact means it cannot be solved by the by the formula we know now. Now next question, x dx plus y dy plus x dy minus y dx divided by x square plus y square equal to 0. Okay, now this is exact difference. Now I can solve this by another method, by arrangement, by arranging the terms. Okay, you can solve it by the traditional formula. You find m, you find n, then find del m by del y, del n by del x. But this is a standard question, means this is very famous question. Okay, this is very famous question, means I can write it VIP. This is a VIP question. It's usual, and all in every book you will find this question. Whatever book in higher mathematics differential equation you buy, you will find this question there most. So now it can be solved very easily. X dx plus y dy. Okay, so I'll write this x dx. No need to anything to do with this, because you can integrate this x dx as it is. Y dy, it can be integrated as it is, plus x dy minus y dx. What I will do, I will do here x dy minus y dx. I will divide x square and then I will multiply x square, okay, equal to 0. Now see what happens. X dx, leave it is as it is, plus y dy, nothing to do with it. Now see what is this. This is your this is see this is your formula. What is formula? This is your d of y by x, okay. See what is d of numerator by denominator? You know, this is denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square. Now see, this is d of y by x, x into derivative of y minus y into d of x by, sorry, not derivative, it is a differential, okay. This is differential, but the rules are equal. D of y by x, x into d of y minus y into d of x divided by x square, okay. So this is this into x square by x square plus y square. Now what I will do here, I will do here 1 by x square plus y square divided by x square, okay. Now this is obvious. So then I will have integration x dx plus y dy plus d of y by x into 1 by, now x square by x square 1 plus y square by x square plus y square by x square equal to 0. Then integration x dx plus y dy plus 1 by 1 plus y by x whole square into d of y by x equal to 0. So now integrating, we have what we have integrating, this is integration x dx plus integration y dy plus integration 1 by 1 plus y by x square into d of y by x equal to 0 integration plus c, okay. Now implies x integration is x square by 2, integration y dy, same formula, y square by 2. Now this is a standard formula. What is this formula? This is tan inverse y by x equal to c. You know, integration 1 by 1 plus x square dx, this is your tan inverse x. The same formula here I can apply here, 1 by 1 plus y by x whole square into dy by x, okay. This is tan inverse y by x. Now this is your general solution, okay. So you can do this question by separating here. You can separate from here dy, then take dy common, you find n, then write all those terms containing dx here. Now separate this and this, dx, take dx common and write m, then find del m by del y, del n by del x, and it will become exact, okay. Then you can solve by the formula, but it can be solved in this way also. So you do how it looks like easy to you, okay. So move to next question. 2x into sine 3y, 2x into sine 3y dx plus 3x square into cos 3y dy into cos 3y, 3x square into cos 3y dy, 3x square into cos 3y dy equal to 0. 2x into sin 3y dx plus 3x square into cos 3y dy equal to 0. Now see, what is m? This is your m. Your m is 2x into sin 3y. Now implies del m by del y equal to del by del y, 2x into sin 3y. Now partial derivative with respect to y, so 2x is a constant. Derivative of sine 3y, so derivative of sine y is cos y, so derivative of sine 3y is cos 3y into 3 is the constant which is multiplied in y, so into 3. So this is your 6x cos 3y. Now then n is equal to 3x square into cos 3y. Now del ny del x, this is equal to del y del x 3x square cos 3y. Now partial derivative with respect to x, so y constant means cos 3y is a constant, so cos 3y will keep it outside. Now derivative of 3x square, 3 into derivative of x square 2x, so this is 3 into 2 6x cos 3y. Now see, both these two are equal, 6x into cos 3y, so del m by del y equal to del n by del x. So del m by del y equal to del n by del x implies equation, this equation 1 is exact. So equation 1 is exact. Now if equation 1 is exact, you can solve it, and its solution is integration m dx. M dx, that is 2x into sine 3y dx. Here y is a constant, plus integration n dy. Now the rule is integration m dx plus integration n dy. Here you will treat y as a constant, and here terms without x, but n is 3x square into cos 3y. There is only one term, it is a single term and it contains x, so put 0 here, equal to c. Now y constant means sine 3y is a constant, so sine 3y keep it outside, integration 2x dx equal to c. This implies this is your sine 3y into integration 2x is x square equal to c. Okay, so this is your general solution, that x square into sine 3y equal to c. This is your general solution. Okay, similarly there is another question. Write x into e to the power xy plus 2y into dy plus y into e to the power xy dx equal to 0. Okay, now first give it equation 1. Now here m, what is m? Careful, m is what? Now here in this question you can be confused, because m is actually that is which is multiplied with dx. Okay, don't write the first term as m, do not write first term as n. This many students do this, so don't write first term. M is what which is multiplied with dx. So what is multiplied with dx? Y into e to the power xy. So m is your y into e to the power xy. Okay, so your del m by del y equal to del by del y, y into e to the power xy, partial derivative with respect to y. Okay, so here del by del y of y into e to the power xy plus y into del by del y e to the power xy. This is equal to y derivative 1, so 1 into e to the power xy plus y into derivative of e to the power xy is e to the power xy into again chain rule d by del y of xy. So this is e to the power xy plus y e to the power xy, again del y xy. So partial derivative with respect to y, that is x is constant, so x into derivative y is 1. So what is this? This is your e to the power xy plus xy e to the power xy. This is your del m by del y. Now del n by del x, del n by del x equal to del by del x n. What is n? N is that is multiplied with dy. What is n? N is x into e to the power xy plus 2y. This is your n. So x into e to the power xy plus 2y. Now so again chain rule, or del y del x, x into e to the power xy plus del y del x 2y, okay, equal to, here apply u into v formula. So del y del x of x into e to the power xy plus x into del y del x of e to the power xy plus, now partial derivative with respect to x. So y is constant, means 2y is constant, so its derivative is 0. Derivative of x is 1, so e to the power xy plus x into derivative del y del x of e to the power xy, that is e to the power xy into del y del x of xy. So this is equal to e to the power xy plus x into e to the power xy into what? Y. Partial derivative with respect to x. So y is constant. So y is constant. Derivative of x is a 1. Del y del x of x. Y is constant. Okay. Partial derivative with respect to x. So y constant. Y can take y outside. Derivative of x. So now this is your e to the power xy plus x y e to the power xy e to the power xy. Derivative of x is 1. So see, xy e to the power xy plus xy into e to the power xy. Here is also e to the power xy plus xy into e to the power xy. So both the terms are equal. So del m by del y equal to what? Del n by del x. Implies 1 is exact. 1 is exact. Now if 1 is exact, now how can you solve 1? Then its solution is given by integration m dx, treating y as a constant, then plus integration n dy, those terms without x equal to c, implies integration m. What is m? M I can write here m, where here I will write m here. M is your y into e to the power xy, and n is x into e to the power xy plus 2y. Okay, this is your mn. Now what is m? M is y into e to the power xy. Now here y is constant, dx plus integration terms without x. Now n has two terms. Now this term contains x, so I will not write this term. This term is without x, 2y, so I will write only 2y. dy equal to c. Now y is constant, so y, keep y outside. Integration e to the power xy, integration e to the power xy dx plus 2y integration is what? Y square equal to c. Now y into integration e to the power xy, e to the power xy by the constant which is multiplied with the variable. What is the variable? X. What is the constant multiplied with x? Y. So divided by y, plus y square equal to c. Now here y get cancelled, implies e to the power xy plus y square equal to c. This is your general solution. Okay, so now let's solve some initial value problems, similar type of questions, but there will be a given condition. Solve 9 into y minus 1, 9 into y minus 1 dy plus x minus 3 dx equal to 0, y of 3 equal to 0. 9 into y minus 1 dy plus x minus 3 dx equal to 0. Now see what is am. Am is that is multiplied with dx, that is x minus 3. So del m by del y, partial derivative with respect to y, so x is constant. So if x is constant, now what will be its derivative? X is constant, derivative 0, 3 is constant, derivative 0, so this is 0. Now what is n? That is multiplied with the dy. What is multiplied with the dy? 9 into y minus 1. Now you will find del n by del x. So del y del x 9 into y minus 1. 9 constant, keep 9 outside. Partial derivative with respect to x, so y is constant. If y is constant, derivative of constant is 0. 1 is constant, so obviously derivative of 1 is 0. 0 minus 0 is 0. 0 into 9 is a 0. 9 into. So both these two are equal. Del m by del y equal to del n by del x. So 1 is exact. Now give it equation 1. So its general solution is given by integration m dx plus integration n dy. Y is a constant, and here terms without x, x implies m. What is m? X minus 3 dx plus integration n, terms without x. Now n has two terms, y then minus 1. Y there is no x here, so 9 into y minus 1, here is also without x, so this is dy equal to constant c. Now integration of x is a x square by 2 minus 3x plus 9 into integration y dy is a y square by 2 minus integration 1 is a y equal to c. Now this is your general solution. Now give it equation 2. What is c? C is an arbitrary constant. C is arbitrary constant. Okay. Now as the given condition, using the given condition y3 is equal to 0, y of 3 is equal to 0, we shall find the value of c. Okay, we shall find the value of c. Now what is the condition? Now see, every condition is like this. We are treating y as a function of x. Y as a what? Function of x. Y as a function of x. So here is y of 3 is equal to 0. Y of 3 equal to 0. Given condition is y of 3 is equal to 0. So from this you can see that what is the value of x and what is the value of y. X value is equal to 3 and what is y? Y value is equal to 0. Okay, as your y is equal to fx, you have learned from your inter in 12th class that y is equal to fx. Similarly here in differential equation, y is equal to y of x. Y is a what? Function of x. Like your distance is a function of time. Okay, there is a formula in electricity, charge and I can't remember that, but there is a formula in electricity, q, I can't remember that. Like your distance is a function of time, similarly y is a function of x. So whenever you find this type of terms, that y of 3 is equal to 0, you just the number, the value inside the bracket is actually the value of x, and this one is value of what? This one is value of y. Okay, so here x is 3, y is equal to 0. So you write putting given condition x is equal to 3 and y is equal to 0 in a 2 x 3. So this is 3 square by 2 minus 3 into x. X is 3 plus 9 y 0 minus y 0 equal to c, implies 3 into 3 is 9 by 2 minus 9 equal to c. This is 9 minus 9 into 2, 18 by 2 equal to c. Implies c is equal to minus 9 by 2. c is equal to minus 9 by 2. Hence required particular solution is required particular solution is just write the general solution replacing c by the value just found here. Okay, so this is your x square by 2 minus 3x plus 9 into y square by 2 minus y equal to c. What is c? There is minus 9 by 2. Now this is the required particular solution. Particular. Okay, this one is called particular solution. This one means you are this is a particular value of c. This is a particular value of c. So that is why the solution is called particular solution. This particular value of c minus 9 by 2. That is why this such type of solutions are called particular solution. What is the general solution? Now this solution which is written with the arbitrary constant c. C is the arbitrary constant. Okay, so let's solve another question like this. Write cos x plus y sin x, cos x plus y into sin x, cos x plus y into sin x all into dx equal to cos x into dy y of pi equal to 0. Now first write this in general form. Your m dx plus n dy equal to 0. All the questions first you write in this form. So this will become cos x plus y into sin x dx minus cos x into dy equal to 0 implies now what is m? What is m? M is what is multiplied with dx, that is cos x plus y into sin x. So what you will do, you will find del m by del y. So this is del by del y. M is your cos x plus y into sin x. Now partial derivative with respect to y. So x is constant. Okay, x is constant. So derivative of constant. A cos x is a constant. Sin x is constant. So sin x, keep sin x outside, del by del y of y. Now since partial derivative with respect to y, so x is constant and derivative of constant is 0. So sin x is constant, derivative of y is 1. So this is your what? This is your sin x. Now what is n? N is your whatever multiplied with dy is n. So what is multiplied with dy? Not cos x. This is minus cos x. Okay, n is minus cos x. That is why I have write this in the general form, m dx plus n dy. Okay, then it will become easy to identify m and n. Now after finding n, you will find a del n by del x. So partial derivative with respect to x minus del by del x of cos x. Now derivative of cos x is a minus sin x. Okay, there is a minus here. Derivative of cos x is minus sin x, so minus minus plus. Now del n by del x is sin x, del m by del y is also sin x. So del m by del y equal to del n by del x. Hence equation 1 is exact and its solution is general solution is given by integration m into dx plus integration n into dy equal to c, integration of n treating y as a constant and integration of n terms without x. Now implies integration m. What is m? Your m is your cos x plus y into sin x. Cos x plus y into sin x dx. Y constant plus n. N, what was n? N here. N is minus cos x. There is only one term and it contains x. So you will write 0 here. Now y constant, now integration of cos x, so integration cos x dx plus y constant, so keep y outside, integration sin x dx, 0 integration 0 equal to c, implies integration cos x dx. What is integration cos x dx? Integration cos x is sin x, y into what is integration sin x? Minus cos x equal to c. This is equal to sin x minus y into cos x equal to c. Now this is your general solution. This is your general solution. Okay, now applying the given condition, now what was the given condition? Condition was y of pi is equal to 0, y of pi is equal to 0. Now just now I told you that this y is a function of what? Y is a function of x. Y is a function of x. So comparing this two, you will find the value of x. What is value of x? X value is pi. What is value of y? Y value is what? 0. So x is pi, y is 0. So you write here, applying given conditions, x is equal to pi, y is equal to 0. Now the general solution, the put the values here, x pi and y 0. X pi, so sin pi minus y 0, cos x is pi equal to c. What is sin pi? Sin 0 0, sin pi 0, 0 into anything is 0 equal to c, so 0 equal to c. So imply c is equal to 0. Hence required particular solution is required particular solution is your push the write the equation to general solution with the value of c. Now c is 0, so sin x minus y into cos x equal to 0. This is your answer. Okay, so there are many questions regarding this type of simple formula, how to solve exact differential equations. You can solve them. Okay, you can solve them. Now in the next class I shall discuss about non-exact differential equations and how to make those integrable non-exact differential equations exact by multiplying a function, and that function is called integrating factor. In the next class we shall learn about what integrating factor. Integrating factor, we call this as IEF. Integrating factor is a function which is when multiplied with a non-exact differential equation, it makes that non-exact differential equation exact. Okay, so